Have you ever come across an exoplanet that causes the wobbling of a particular star, and this exoplanet is really close to Earth? We're going to check out this particular exoplanet not only in terms of its characteristics but also the significance of it in our understanding of the solar system relative to Earth, and also other things that are happening within its own system with respect to its star. So this particular exoplanet here is called Epsilon Indi Ab, and this here is an exoplanet that is around 12 light years away from Earth, and interestingly enough, it is the 12th closest exoplanet to Earth. Now, looking at this particular video, we're going to look at seven things to keep in mind when it comes to this particular discovery by James Webb Telescope regarding this particular exoplanet. And the first thing we're going to look at here is the temperature of the exoplanet. Second is the mass of this exoplanet relative to a particular planet that is within our own solar system, Earth, followed by the orbit of the solar system of this particular exoplanet, followed by the James Webb Telescope image and what that reveals. And this will give us some interesting challenges that scientists went through in order for them to obtain this particular image, and this will lead us to what are the expectations versus reality that astronomers came across when they were investigating this particular exoplanet before and currently and the future. And finally, here is the significance of this particular discovery of such exoplanet that is really close to us, which is our planet Earth. So let's begin with the temperature part of this exoplanet. Now, looking at the temperature, it is revealed that this here is one of the coldest exoplanets to date, and this here is followed by our understanding of how much cold. It states that its temperature is a few temperatures above absolute zero, and this here in terms of a specific number is around 2 degrees Celsius, which approximately is the same thing in Fahrenheit to be 35 degrees Fahrenheit. And when you talk about how this temperature is like compared to any of our specific planets that are within our solar system, is pretty much warmer than that of Jupiter, which is in this case, in terms of the value, around 100 degrees Celsius warmer than that of Jupiter. So it's pretty incredible to see or recognize how cold Jupiter can be, and how this in comparison to this exoplanet is still, this exoplanet is super cool with respect to other types of exoplanets that they've discovered. Now, in terms of this particular exoplanet's mass, it is considered to be a gas giant exoplanet. In terms of equivalence, it's pretty much in the category of Jupiter in our own solar system. However, in terms of the mass compared to that of Jupiter, it says that it is several times the mass of Jupiter. It doesn't give specific number as to how much times it is, but it's going to be interesting to see more when more investigations kick in with regards to this particular exoplanet comparisons to that of Jupiter in terms of the actual values or numbers. Now, when it comes to the orbit of this particular exoplanet, it is considered to be in the region of the K-type star, that is the Epsilon Indi Ab system, and this particular star that this exoplanet is in the classification at is pretty much at the same age bracket as that of our own sun. But in terms of the temperature difference, it states that this particular exoplanet star is colder than our own sun. So it's going to be interesting to see the challenge that these particular people here in terms of these scientists were able to overcome with respect to this particular information that we've gathered, not only based on the mass but also temperature of that particular exoplanet and also the temperature of its host star. Before we get into the incredible discovery by James Webb Telescope in terms of the imaging, there is one challenge that scientists had to overcome, which is considering that we confirmed that this exoplanet here is a cold exoplanet. Cold exoplanets in general tend to be really hard to detect. Reason is because they don't emit that much heat that is detected by these telescopes. Therefore, because they are getting cooler, they tend to contract, which means they radiate less energy. So now, with regards to James Webb Telescope, this particular instrument here uses its coronal graph for it to be able to detect this particular exoplanet. And it's really fascinating here because this coronal graph is connection with the mid-infrared instrument of James Webb Telescope. Therefore, this here enables us to, one, block out this particular star with the help of that particular image where you have the 5-edged star with a circle around it, and this here is done to locate, one, the whole star, and two, to block it off. And this is followed by the next step here, which is how about we use the James Webb Telescope's mirror, which are the large mirrors for it to separate the planet from the specific host star. So this incredible collaboration was important for this particular image to be shown right here, and there are various colors that we see right here based on the wavelength. Those here will be explored in detail. Now, the expectations astronomers were going into this particular image was, or before this discovery, was that, hey, this particular exoplanet, since it is that massive here in terms of the size and how close it is to its star, it could cause a little bit of a wobble acting on that particular star from this particular exoplanet due to the gravitational pull situation, as this particular exoplanet is orbiting around this particular star, and this wobble will be observed on Earth in terms of a shine and dawn situation where you have a squeeze of the light, which shows that this particular star is closer to Earth's view, and we have a stretch of the light which shows that this star is further away from Earth's view. And that was the expectations here from astronomers. However, the reality is that this particular exoplanet is known to be twice as large as expected, and furthermore, in terms of the further away it is from the star, it is discovered to be a little bit further away than expected, followed by the understanding that yes, this particular exoplanet actually follows a different orbital path than expected. And finally here, in terms of the atmosphere, it is discovered now to be completely different. We'll talk about the expectations now for the atmosphere based on the discovery by James Webb Telescope. So now moving on to the final part here, which is with regards to the significance of this particular discovery of this exoplanet. This here is a great opportunity to discover more about this particular exoplanet's atmosphere, and this atmosphere here is really instrumental based on the images that will be coming in the future at different wavelengths, and most importantly in terms of the atmosphere based on what is being seen based on this image. It is speculated that it has elements of methane, compounds like carbon monoxide, carbon dioxide. Therefore, it is assumed that this particular exoplanet has a cloudy atmosphere, since the compounds that are listed, they do absorb at a shorter wavelength. So it's going to be interesting to see how future explorations will explore the different types of wavelength and see whether there are other possible compounds that are present in the atmosphere that may give us a little bit more range and complexity to this particular atmosphere of this exoplanet. Now, in addition, there should be more wavelength that needs to be taken, not only in combination with the photometric but also using the spectroscopic view of this particular exoplanet with the help of James Webb Telescope. In addition to this, we can also use the future telescope that will be put out there, which in this case is called the Roman Space Telescope, and this here will help us to look more into the chronography of this particular exoplanet with respect to its own star. So I hope you found this really informative in terms of all the things you need to know about this particular exoplanet Epsilon Indi AB, and I hope to see you all on the next one. If you have any comments or suggestions, you can drop that into the comment section and let me know your thought. Also, the article is in the description, by that way you can see more details and data in the description, the link right there. So hope you found this really informative. See you on the next one. Stay smart as always and believe in yourselves.